I think this could open up a window of interesting innovation on the government side where you just don't have to spend as much in the hardware commitment in order to create a capability that opens up exposing your data in prompts to the model. It opens up fine tuning to the data that you have in your agency, et cetera. I think that's really interesting. And I believe it could be similar on the commercial side.
This is the AI Leadership Podcast by AI Leaders. Practical, to-the-point content helping you drive results with AI. Here's Chris and Frank.
Hi, welcome to the AI Leadership Podcast. I'm Frank Strickland.
I'm Chris Whitlock.
We normally open the show talking a little bit about what we've seen in the wild, and we have a topic that we have seen, a single topic that we're going to talk about that a lot of you are interested in and all of you have seen, and that is the breakthrough of the DeepSeek large language model. And so we're going to go through a few segments on DeepSeek. First, just doing a little context setting for those of you who may not have context on the large language model landscape and especially investment in hardware. And then we'll go through some performance data on DeepSeek against some AI benchmarks. And then we'll talk about how does it appear they're getting the performance that they're getting, and then some implications, especially some implications that could be very interesting for government leaders. Before we dive in, Chris, for those that are new to the podcast and just new to us, what is our background in summary, and kind of how do we come to the points of view that we have about AI?
We've worked for several decades around different modeling techniques and advanced analytic techniques, chiefly in the public sector, defense and intelligence related. But for the decade prior to retiring, heavy emphasis on AI. I led a number of big contracts that deployed machine learning and AI solutions in the government space. Frank similarly directed software initiatives and analytic efforts more in the defense and intelligence community arena. And after retiring, we've been teaching and writing, have taught for over 5,000 executives over the last year and a half or so, and written a book on implementing AI in the national security community.
Okay, so to give you some context as we approach some details about DeepSeek and what it's accomplished and what that might mean to you, we are in about a 7-year period now where first Google, with a body of research, with a seminal paper entitled Attention is All You Need, and then a body of research, development, experimentation, and model publishing by a number of companies now around large language models. And so we have course material that if you want to immerse yourself in how large language models, you can do that. But for now, what we want to set as context is the tremendous amount of investment that has been made in the hardware, in the IT infrastructure for the training and the operation of these models. And just kind of a couple of data points that contextualize this for you. Most of you have seen recently the announcement of the Stargate project and a consortium investing $500 billion, $500 billion in AI data centers and AI-related research. You can have your own points of view about, whether that full 500 will become material or not. But there is an $80 billion commitment by Meta in their own AI research, tremendous amount of investment by OpenAI, tremendous amount of expenditure. Just to give you one data point from OpenAI, when they trained the current version of GPT and series of GPT, it's based on the GPT-4 model, so ChatGPT 4o as an example. the training from GPT-3 to GPT-4, according to Sam Altman, the CEO, they spent $100 million just on the training.
It's amazing when you think about that. And I think it's fair to say, Frank, for the large scale solutions that many of us use, like ChatGPT, et cetera, those are still in a loss leading position. They're creating capability and running it, but they're not making money in a profitable sense yet because the expenses are so significant.
Yeah, so you have an environment where the perception is, and more than the perception, the engineering and the investment is we need to build larger and larger models in many cases in order to get higher and higher performance across a wider range of topics. I would suspect that the vast majority of you listening have used ChatGPT, you've used Gemini, you've used Claude, you've used one of these models. And I know I've had to go in recently into my GPT and just organize the projects I had because I had about 36 different threads open of everything from math and physics and coding to history to language to copy editing, et cetera. So the emphasis has been on for a subset of these models to make them larger in order to make them more performant across a wider range. And those scales required a tremendous amount of investment in the compute hardware, which has helped to do things in the market like drive the NVIDIA stock price, et cetera. So that's kind of the context setting for you. The big takeaway there would be scaling these models larger and larger, and the hardware necessary to do that in order to train and operate the models, and the investment then required in order to develop and acquire that hardware.
Frank, I think there was another facet of this that was interesting as well. And it was the big debate and discussion immediately following DeepSeek's announcement. Some were musing, have they changed to an entirely different modeling approach than what we had from 2018 to today in the transformer architectures? And I think it's clear now, no, they didn't. They're still using fundamentally the same kind of approach in modeling. The change in the way that they've gotten the gains are different. And it's not by changing the macro modeling approach per se.
Yeah. All right. So with that, let's pivot and look at some of the performance data on DeepSeek's models, and then we will look at a bit of how they are publishing, at least they've gotten to this performance. Okay, let's look at some data on how the DeepSeek models are performing. And for those of you on YouTube, what you see here is a chart from a DeepSeek research paper that shows DeepSeek version 3 and version 2.5 tested against 4 other prominent models. Won't go through all the models, but OpenAI, Meta, Anthropic, one Alibaba model, and 6 AI benchmarks. And I won't go through each of the benchmarks either, but let me just give you the high points. If you take the first 2, these are mainly text-based, and they're against a broad range of domains, science, history, etc., lots of wide-ranging topics. And what you see there is the DeepSeek version 3, the most recent model that was released in December of 2024, is performing better than most of the other models and almost as well as the best performing model. What is interesting in the other 4, and what's mainly interesting to us about what DeepSeek has done, is they have taken a different approach to the training of the model. And the different approach Chris is going to go into in a bit more detail in a moment. but that different approach has enabled the model to perform really well against mathematical reasoning and mathematical problems and software problems. So 2 benchmarks here related to math, 2 related to software, and you see the DeepSeek most recent model is performing extraordinarily well against these benchmarks. If you
Yeah, it's
pivot,
attention getting when you look at that chart, Frank. It's attention getting, especially for the science and math, reasoning and computation. They stand out.
indeed, if you pivot, if you look at Hugging Face, for those of you who are not familiar with Hugging Face, we'd encourage you just go to the site huggingface.com. Tremendous repository for open source AI models, open weights AI models, and they have a number of leaderboards where models are being competed against one another. There is a chatbot leaderboard, which is pretty standard in the industry. And you see here the DeepSeek model is performing remarkably well. It's tied for third, and it is performing remarkably well on this chatbot leaderboard against things like Gemini, ChatGPT, et cetera. So net is there's performance data out there, not just assertions that would cause you to sit up straight and look at what DeepSeek has accomplished and say, wow, they're performing really well against some of the largest, most sophisticated models that are out there in the AI ecosystem.
Yeah, it's impressive. It's impressive.
If this content is of use to you, we encourage you to subscribe to our YouTube channel and give this episode a like. If you're listening to this episode on Apple or Spotify, please take time to give us a 5-star rating. And if you have a moment, leave us a quick review. You'll find more resources like this podcast and training courses at our site, aileaders.com. Let us know what you think. We value your feedback.
Frank, to me, what's really remarkable about this, the performance is tremendous, what you characterize. So they have done very well, and they're outperforming in science and math, computation and reasoning with some of the changes in the model or modeling technique. They use a mixture of experts method, and they use chain of thought to help address the reasoning and computational components. They changed the way that they were training the model by emphasizing reinforcement learning for the math-oriented portions and science-oriented portions. And that's a rules-based check that normally you wouldn't associate with this kind of model at the scale they were talking about, but very, very cool. But that to me is less the story than the hardware. And to me, that starts at a level with this 2019 McKinsey report. They do excellent work as it pertains to research. And their bottom line in this 2019 view was, wow, what's happening in the AI space is fundamentally shifting expenditures in the direction of hardware. And where hardware has historically been maybe 20% of the AI stack, it could well garner 40 to 50% of the expenditure in the AI stack going forward. Well, if you take that in 2019, if you go forward a slide, last year at this time, Sam Altman, the CEO of OpenAI, was looking to raise $7 trillion to reform the semiconductor supply chain because hardware was a real limiting factor in our ability to advance and progress towards general AI or super intelligent forms of AI. That's how prominent the hardware story has been. And there have been a whole batch of companies led by NVIDIA that have been at the center of this much more hardware-oriented approach to AI development. And this is what you were hitting on in the upfront, right? We've been pursuing bigger and bigger models with the hyperscalers, but there's been this divergent emphasis on smaller models to do particular tasks, et cetera. And in comes DeepSeek. And where's the innovation? This next chart, there's a fellow who has written a fantastic article, and his name is Jeffrey Emanuel. Really well done. He highlights 5 primary drivers on the efficiency that DeepSeek has achieved. And then there's a batch of others that might constitute a 6th. I'm not going to go through these in detail, but I think what's important here is they innovated in software. So in the first instance, mixed precision training framework, they shifted from 32-bit processing to 8-bit processing, which you would expect to be less data and potentially less quality. What they did was to sustain quality and use a ton less memory, which means we need less compute to do the task. These models, the second innovation that they did in software, without changing the kind of model, they went from predicting the next best token, single token, to predicting multiple tokens at the same time. So it's faster and it uses less memory and it still retains quality. They changed the way that they were holding what we would call importance values or key values in memory. And this is that attention function you raised, Frank, the Google breakthrough with attention heads and the transformers. But a memory pig on that is key values. Those are held as the machine is processing this information, and they came up with a way to economize on that in the software. Didn't change the hardware, in the software. And so it goes. We don't need to go through all of these, but I think the story is their innovation is around being very clever and creative in software engineering. It's not the AI approach per se. It's in the software engineering that attends every element of this. And it's pretty remarkable what they have done. To give a couple of comparative data points, when OpenAI was training GPT-4, the most current version, reportedly they used about 25,000 graphical processing units to support that. These guys use 2,000.
Yeah.
That's how vivid and remarkable the difference is on hardware efficiency. And all of that comes out of software change. And to me, it's amazing what they've done. It's fantastic what they've done. And it's going to have implications that are still to be seen.
Yeah. I'm mindful, Chris, of some of our former colleagues who were computer scientists who would want you to say software/computer science, but not hardware. In fact, this is kind of a classic story, and those who are into tech history or just into history in general will resonate with this at a level. The sparsity of their resources, meaning the DeepSeek company and their team in China, the sparsity of their resources, in some respects, you could say, led them to innovate in doing things that, frankly, I kind of scratch my head, Chris, and wonder if you take multi-token prediction, gigantically smart people at OpenAI, Google Gemini, Anthropic Claude, et cetera, and maybe there is research going on in this space, but predicting in the training on a single token, which for those who don't, that term is foreign, token, just think word or subword, to predicting based on multiple tokens and still getting higher accuracy and therefore increasing speed and lowering the memory requirement. It's a case of sparsity of resources drives them to think about different ways of doing it. It's just really
That's a great point. It's a great point. And pretty fantastic breakthrough by all appearances in what they've written and critiques of people who are looking at performance and looking at what they've done.
Yeah. So let's take a short break here, Chris, and then we will come back and talk about some implications, especially for government executives and government leaders. So, Chris, let's finish up by talking about some implications as we see them now.
Some things that immediately strike me, Frank, that I think it's going to take a little time to see how it fully manifests. But if you're in the government arena, especially if you have sensitive data, you may operate on the secret or SIPR network in the national security community, on the highly classified network, JWICS primarily, but there are other permutations. Even in parts of the civil government, before the big limiting factor was having to share data that might be varying levels of sensitivity and therefore precluded with OpenAI or Google Gemini, et cetera. And we've seen initiatives for them to manifest their capability on the government side. I think this could open up a window of interesting innovation on the government side where you just don't have to spend as much in the hardware commitment in order to create a capability that opens up exposing your data in prompts to the model. It opens up fine tuning to the data that you have in your agency, et cetera. I think that's really interesting. And I believe it could be similar on the commercial side where you have had intellectual property concerns, privacy concerns, et cetera, that might limit a business's orientation to share data with an OpenAI capability, Google Gemini, Claude, et cetera. There may be some where it becomes attractive now to look at creating a fairly robust, high-performing model instance, but on their networks. That to me is going to take a little time to play out because those decision-making processes are inherently decentralized, right? Every company is going to have to do it. You're going to have to rally people around the need and whatnot. But I think DeepSeek may have opened the door to some interesting changes in the way that this market unfolds, to include startups and the way that startups come at this kind of capability development.
Yeah. And it's a dynamic environment. And, I am sure that some of the data scientists listening, as we've been talking about these hyperscaled models or these very large, enormous, high performant models across a wide range of domains are thinking, yeah, but I use smaller models, 7 billion parameter llama, yada, yada. And there is a tremendous amount of activity that is going on not only in the hyperscale, but in the smaller models, in the proprietary models like Google, like OpenAI, et cetera, in the open weights models such as DeepSeek and many, many others, Meta's, Llama. So it's a very dynamic space. One thing we would encourage leaders to do is don't fall for the hype and don't fall for the hysteria. There is just a natural tendency.
There's a good bit of doom and gloom right now.
Oh, Judas Priest, and a good bit of hype. All respect to Eric Schmidt, just tons of respect to him. But, when he said this space is underhyped, it's like, maybe, but sure feels like there's a lot of hype. We would encourage business leaders kind of with this, have your eyes wide open to opportunities and your feet firmly grounded in reality. And that's really what our writing and courses have been about. Eyes wide open and feet firmly grounded. And there's going to be a lot that we're going to learn about DeepSeek. There's going to be a lot that we learn about competitors' response. The DeepSeek tech paper is out there. The people at OpenAI, at Anthropic, at Claude, and Anthropic and Google, elsewhere, these are smart people. There's a lot of innovation. There's a lot of churn, a lot of dynamism, which is great in this space. So just, don't run for the dark corner of the room and don't run out of the room with your hair on fire, screaming and waving your hands that, we're one day away from nirvana.
It is fascinating there too, how our minds play around this, Frank. I mean, I was looking at some dialogue as this first broke that, this must be liquefied neural nets. They finally made it happen on an operational scale. No, actually, it's not. They've been really clever with, basic techniques, et cetera, really clever in what they've done and its breakthrough, but it was not the woohoo, the world has changed, liquefied neural networks. There's some righteous concern about hardware, and it does make me like a key watch element right now is Stargate came out with all that fanfare. Even a White House, facilitated an announcement about $500 billion of investment. How does this change the economics of that? And do you need that same amount? I'm curious. OpenAI has an enormous infrastructure today. At some level, DeepSeek has just given them a gift. They've given them a gift to say, hey, this is actually how you run the software much more efficiently. Well, if OpenAI went that path, they now have a huge infrastructure they can use for other things. What are they going to use it for, right? It's not all doom and gloom, as you're saying. There are angles here, and there are issues to watch. What's clear is it's a big change from a year ago or 5 years ago on hardware. And it's not that the hardware goes away, but we've certainly seen something that lessens the dependency on that line of activity. And hardware leads to power, leads to water, leads to facility construction. This breakthrough on the DeepSeek front is really interesting there.
Yeah, Jan LeCun, who is an NYU prof and also the chief data scientist at Meta, that was his exact take, kind of his macro take, Chris, was that DeepSeek has done a favor to the community. Meta publishes Llama open weights. They advocate openness in the research. This, for those who kind of like to understand the history, and that helps them kind of assimilate other information. The 2017 kind of wave that we talked about began with a Google research paper that was published in the open. But things started to shut down in a lot of proprietary efforts pretty quickly when you started talking about hundreds of billions of dollars of market cap. So, LeCun's point is that DeepSeek has done a favor. The answer is just our advice would be just be wary of anyone who has broad sweeping concrete conclusions. There is much more dynamism, much more to be learned. Just eyes open, feet firmly on the ground. So hope that was helpful to you as business executives, as mission executives, and also to the data science community who want to do a good job in talking with the users that you're serving about these things. You can go to our website, aileaders.com, to learn more about AI Leaders as an AI solutions company. You can also go there and learn more about Chris's and my training and writing. But we have appreciated this time with you. We'll see you back next time. Appreciate you.
Indeed.